Well, thanks for coming all. We'll go ahead and get started. So this presentation is going to talk a lot about some of the edge technology that's used at Netflix. And by edge, we mean what your Wii's and such hit first in the network. And go over some Java software that I've been working on as a part of Netflix. So I'm Adrian Cole, the other Adrian Cloud guy. There's Adrian Cockcroft, who also writes a lot of presentations and works right next to me. And I started at Netflix in late December last year, after spending about 4 years on an open source project I founded called JAXConf. And I've been working on cloud portability at Netflix with regards to DNS. And so you hear a lot about that through the mix, and I hope you found yourself in the right room. So how many here know how Netflix streaming works? Okay, well, issues are a few and no hands for the rest, so that won't be boring. How about DNS in general? How do people feel about DNS? Thing that puts names to IP addresses? Yeah, that works. So I'll always go through a little bit of DNS just to make sure it's not complete Greek. But this won't go into like deep 20-year, 400-page book DNS stuff. I'm intentionally avoiding that because if you're really interested in DNS programming, you can always join the open source project and talk to me after the session. We'll go over in depth the Java code that myself and others in the project have been working on. It's called Denominator. And this is part of the NetflixOSS GitHub repository. How many here use GitHub? So quite a few. GitHub, for those who aren't using it, is basically a source control, collaborative source control that's free for developers. And we have repositories in Netflix about, well, a few dozen, I guess. And all of the code that are in those repositories are things that we actually use in production. So, and we don't have forks internally either. So it's a very interesting place because you can literally see the bits that are responsible for playing your favorite films or documentaries or TV shows. Finally, Cloud Prize. Have anyone heard about the Cloud Prize before, the Netflix Cloud Prize? One hand. I have 2 hands. 3 hands. All right. Okay, not so bad. Have a bit at the end discussing the Cloud Prize. In short, we're doing our own sort of Emmys for open source software. And the Cloud Prize will have 10 categories of awards for contributing and improving the Netflix open source ecosystem. And there will be a panel of judges, some pretty famous folks there. And the winners will be given $10,000 each. That could be a person or it could be a team of people, as well round-trip tickets to go to the Amazon re:Invent conference later this year, which is where the award ceremony will be. So it's kind of fun, and I'll spend a couple minutes just talking about that too. So this is where it all starts, right? And this changes. Some of you have seen Netflix change over the years, although the branding is pretty consistent. The content definitely does change, and it's personalized. You'll have noticed there's a number of recommendations coming from what's generally popular or what's popular to you, or folks that have hijacked your Netflix account. This is actually not mine. This is the other Adrian's Netflix screen grab, but I suppose I wouldn't mind seeing those shows. But we're going to talk about how that content gets there. And in a nutshell, it's a distributed system. How many here have heard about or knew that Netflix uses the Amazon cloud for some of its architecture? And so that's pretty wide known. One of the things that's really good for cloud computing in general is that Netflix has kind of trailblazed a lot of stuff in the earlier days of Amazon and helped get Netflix and Amazon through some scaling issues. So a lot of folks who use Amazon now probably have a slightly better place because of the collaboration over the years. It's been a very good relationship. But Amazon is not the only cloud that we use. So for example, all the bits in the movies, you can think of the films being split up into various like 1 or 2 second pieces and distributed all over the place. And they're encrypted, and the massive amount of data that is actually on a content delivery network. And that's actually a cloud service. How many have heard of the term content delivery network before? So a good majority, but those who haven't, it's basically like a cache network where whoever the client is going to be getting content closest to where they are. Super helpful when you've probably heard the statistic that Netflix is responsible for 1/3 of the bandwidth in the US. Optimizing where those bits are coming from close to the user is really important. And that's actually the majority of the Netflix traffic. And I'll go into more of a breakdown there. So we certainly do use Amazon for just about, well, our entire control plane. We basically, I think we may have a server or two left in the data center, but it's been pretty much all redesigned for the cloud. But most of the content is served through this service that's a combination of existing large-scale CDNs, content delivery networks, and then our own thing called Open Connect. And of course, nothing will work at all unless there was a client player. And so Netflix is also works tight with device teams to make sure that not just Silverlight, but other things like your Wii's and your PlayStations and everything can connect and use those protocols. So for example, what generally will happen is it's a series of RESTful metadata API traffic that's responsible for Netflix delivering your browser or whatever content. And that metadata is going to have things like the thumbnails of the films that you see, the recommendations. If you vote on it, that's going back through a REST call. When you start to play, the whole licensing dance is going through the REST APIs, and you're going to get basically behind the scenes is actually kind of assembling a playlist of sort of video audio packets that are going to be pulled by you directly from the content delivery network. If you tried to make your own dumb version of Netflix, what you would probably do is split up your films similar to a BitTorrent, put them on Amazon S3, and dole out signed URLs for temporary periods of time. That would be a really dumbed down version, and obviously Netflix is more complex than that. Our content delivery service, Open Connect, is an open hardware spec, and is basically what we do is in order to kind of reduce the burden of Netflix traffic on all the ISPs and the exchanges, we have our own exchanges that will basically help install these appliances on an ISP, which would help prevent the traffic that would otherwise go from all those films from consuming their uplinks. So what will happen is that we would actually manage the catalog and distribute it to all these little ISPs that might have Open Connect boxes running in them. So it's a sustainability effort to help get less of that uplink saturated by only Netflix traffic. And so it's good for the ISPs, it's good for us. Users get better performance because they're getting their content directly from their ISP's network. So there's a lot of good information about Open Connect, and you can just check that out on the website or ask folks later. This is the traffic. We have a wonderful program as Netflix employees. Inside, you get the ability to see the how everything works. We have this Netflix University. And so in November, the folks that are responsible for all of our content gave us a nice class about how all this stuff works. And it's really nice. As Netflix employees, we have access to all of the information that maybe I can't talk about, the specific, how many people use Netflix from here or there, but we can internally. So this is a washed slide from an internal presentation of some information that we can publish without violating our shareholders. And what this shows is that as of November, Netflix, is responsible for, a vast majority of U.S. traffic coming down, but it's also pretty high up there as far as uplinks too. And that's the API traffic. That's a lot of the other things that are coming from people's devices. And so it's a significant amount. And a lot of that uplink traffic is actually coming through our services on Amazon S3. On Amazon Web Services. So basically, this is like we have a farm. Folks may have heard that our region in US East is about 10,000 machines. And then we have another region in UK that has another few thousand. In Ireland that has another few thousand. So there's still quite a lot. And 4.5% of the upstream traffic is no small deal. So our cloud is used quite a bit. And the one way to figure out the control traffic is to look at the uplink. We also worked with a company called AppDynamics for a few years now, which is one of our monitoring services. We use a lot of services, and they've grown over time to help us make sense of our graph. When you have a graph of several thousand servers, even if they're bundled into clusters, you still end up with a deal where there's a lot of complexity to figure out what your dependency graph is. And so our dependency graph is pretty widely known that we're big Cassandra users. We use Cassandra for a lot of things, and one of the merits we have is that it helps us deal with multi-region replication, meaning that we can take content and use Cassandra technology, replicate it between like East Coast and West Coast, or between Europe and US. And so that helps us a lot for the content that we do need to globally synchronize. But we also use a number of other things. We use Memcache clusters, we use S3, we use Dynamo, SimpleDB. We use a lot of Amazon Web Services. And so our graph has to be able to represent both things that we run and services we rely on when we're looking at actually what ends up working through. So this is just sort of what a starting point, like where the start point is basically our API server, and they have to connect to all of our 200 microservices inside, and what that actually ends up looking like. It's kind of hard to look at, to be honest. How many here have heard of Asgard or have seen Asgard? Asgard's like our command and control console. It's sort of like a replacement for Amazon's web console. And it does a lot of cool stuff. And it actually recently can do pretty sophisticated things like workflow deployments because it's going to be integrated with Amazon's simple workflow service, which would allow us to do things like staging deployment tasks, multi-step tasks. But before getting to something too fancy, what you see is just basically how we release apps. We use this concept called auto-scaling groups. And the ASG in Asgard stands for auto-scaling group. And so when we roll out, everything's a cluster until proven otherwise. So auto-scaling group can have a fixed or variable number of servers in it. And we bake an AMI with a project that's open source called Aminator. And it will have a naming convention, including the version of the deployment. And so Asgard sort of built around our deployment model so that you can release and put more or less traffic on clusters that are often, but not necessarily, fronted by load balancers. So for example, a lot of our internal services, we connect with our discovery services directly called Eureka, as opposed to using a load balancer. So the DNS side of things comes into play more often when we're talking about multi-region, meaning that just having an IP address of a load balancer is not enough. And so it's the same issue with inside the same region if you had redundant entry points. But in a happy world, what we're going to be able to do is use our various DNS providers and control them in a similar fashion so that when someone resolves to, say, one of our API endpoints, we can point them and allow them to have the ability to fail over to a new load balancer or an existing load balancer that's healthier than the one they're currently using, or even move their traffic over just to facilitate an upgrade. Netflix does a lot of product testing and a lot of system testing, and oftentimes we will, before we do something major, we will move like a couple states over to this new service, make sure it works properly before turning on the floodgates. And that's not just states, but countries. So the project that I've been working on since being at Netflix is called Denominator. The first production deployment of that was actually barely after it finished back in March in this Open Connect. So when new appliances are being registered, they're being auto-registered with DNS. But we also use it for naming our load balancers and shifting traffic between them. So it's a cool logo, thanks to Jeff Demick from UltraDNS, who found the app that generates things like this. And so we have a number of use cases, multi-region failover being one of them, but we also have things like EDA, which is our service for sort of understanding the audit log of all of our configuration over time. And then, of course, things that we didn't necessarily plan on. For example, the introduction of Denominator into the cache service happened without me knowing it. That's pretty cool. And also, when some of the folks in our deployment teams were looking at Denominator to register our EC2 instances with DNS on boot up, just to give them a more friendly name than I-whatever. The common model is a model on DNS, and then we have plugins, which we call providers, for each of the services we use. Netflix currently uses 3 different DNS providers. Amazon for internal stuff. We use Dyneck. Dyneck does most of our CDN. And these are going to be tens of thousands of cache nodes. And then we use UltraDNS predominantly for all our API. And so for example, anything that Asgard controls typically is registered in UltraDNS. And they're all different API models, mostly broken. And so this is one of the challenges, is that some of the clarity you might have with certain modern APIs, like GitHub's a pretty good API. None of these are like that. So some of the feature sets that we were focusing on with Denominator were to do things in batches, because particularly we have some pretty large zones. And so if you have something with 10,000 records in it, then you're not really going to want to do those one at a time. You end up with, instead of constant time for operations, you end up with linear time, which really hurts you if you have a lot of records to deal with. Also being able to cleanly handle advanced records, and I'll talk more about advanced records, but basically anything that has a server-side profile, like for example, if it's latency optimized, or if it's bound to a certain set of geo territories, this would be something that I would refer to as an advanced record. And play nice with persistence. Because we persist internally, we interact with this and we back it with a service called Denominatrix, which is a control plane that's built on Cassandra. And we want to make sure that this data is easy to query and easy to get in and out of JSON, stuff like that. So, and finally, don't do too much. Netflix has a lot of projects for things like resiliency and command retries and circuit breakers. So we want to make sure that each of our components we design are not also doing all of those things, because then you just end up with a complex web. We'd rather bolt on the things that we need. So we want to make sure that Denominator doesn't try to do too much, because we have a lot of tools for doing the system aspects that we can just use around them. One of them, for example, is a service we have, Livin, which is a client on the open source site, and this allows like a normal REST or RPC client to be able to use load balancers and things like that. So we don't need to deal with like the retry and a for loop stuff that you end up having with REST clients. Cool things is also important. It keeps you motivated when you're working with SOAP. So this is what it looks like to start Denominator from Java. And this is one of the things that most people don't really like so much is the fact that it uses iterators. And there's two reasons for this. One is that we have a pretty cool project called RxJava, which is functional reactive programming. It's an observer model. And observer model is a fantastic way of aggregating resources. And things like lists and things are less good, but particularly they often lie because most of the contracts for things like iterable imply that you're supposed to be able to replay things. You're supposed to be able to call iterator more than once. And because these are network connections and trying not to do that too much thing, we don't want to cache this data, particularly because it can blow up your heap. So the optimization is that, okay, we will probably have a functional reactive model which will allow us to push like zone information to you. And in the meantime, we don't want our normal like iteratory thing to be too cachy just because there's a short form of the for loop in Java for iterable. And so that's the rationale, and I'm positive some folks are not going to particularly care for it. But I figured I'd put it out there just so your blood can boil a little. When Denominator creates, a lot of our providers have multi-part credentials. So some of them have just a user and password, some of them require a tenant, and some other things like that. So we have some mechanisms to support variable length and map-keyed credentials in abstract, as well as the ability to do that on demand from various suppliers. For example, we have a service, a ribbon that allows it to inject things like endpoints dynamically based on what's registered in Zookeeper. So we might get things from different places. But this is a way to statically define it. DNS lingo. So zone is what a lot of people call a domain or a subdomain. Technically speaking, DNS is a tree, and it makes things really complicated if you think too hard. So zone is sort of a noun that's defined in like the main implementation of DNS called bind, and we're using that word. Most people use it. Records are things inside of it, and so records are really the things you tend to be looking up. Zone is like a namespace for those records. Now, what most people get confused about in DNS is like CNAME versus A. And basically, in DNS, there's a kind of a record format. And on the far right is the data, and the far left is the name of it. And the type is describing what's on the far right, what's the data. So if the record name is A, then that means that there's an address at the right-hand side. That's an IP address. If it's quad A, it's an IP address 4 times as big, which means it's an IPv6 address. CNAME means canonical name. And it's an interesting thing because canonical implies the one, like the Highlander one. So if I have a CNAME, then I'm pointing to my like canonical name. What is the real name for this thing? So if you're making a DNS record and you're putting a name in the field for data, it's a CNAME record. And CNAMEs are weird because of this implication of being canonical. Means that a CNAME can only have one name at the right-hand side, whereas an address is not trying to be. So I could put a list of IP addresses there. I could give 8 IP addresses, and then my JavaScript could just round robin through all of them, because in one DNS query, it's valid to have many IP addresses returned from an A record. CNAME, because by definition it can only have one, like Highlander one, then if I have a JavaScript thing that pulls back that, I'm going to get one value. Now I can resolve that back to IP addresses, but the one value thing makes for advanced records. So basically you would probably want to, for availability concerns, be able to allow the client to use multiple load balancers, not just one. And so this is sort of how we start getting into advanced records. When writing Denominator, we optimize for record sets. This basically means anything with the same name and type. So Neflix.com address type record. You might have several IPs coming back to you. Those would all be in the same record set. And this is also helpful because DNS security, DNSSEC, likes to sign things based on a query tuple, and that query tuple includes the name and the type. And so there would be a corresponding signature for that name and type. And so for DNS records that need to be signed, you have to really aggregate them into record sets anyway. Very few people do that because there's a lot of maintenance involved in DNSSEC, but that's one of the reasons why. DNS things, name servers are servers that typically listen on port 53. That's why Amazon services named Route 53, upon on Route 66, but using port 53. Resolver is a thing that's asking the server's questions. And so the resolver could be inside your Wii. It could be inside your Java virtual machine. It could be delegated back to your OS X or whatever it is that you happen to be using. But the resolver is the thing making the questions. The name server is the thing trying to find the answers. And when I use the word API, of course, that can be used for anything. But I'm just trying to differentiate between sort of the line of fire stuff, which is between this resolver and the name servers, and your control plane work, where you're actually going through and trying to reorganize your domains or your records. And that's what I'm going to use the word API for. Now, Dagger is pretty cool. How many here have heard of Dagger before? And I'm switching to Java, by the way. This is not a DNS concept. How many here have heard of Juice? How many here have heard of Spring? Okay, we got Spring, definitely. So Spring, and a lot of people know Juice. So Spring is literally 10 years old, I think, maybe as of a week ago. Spring popularized dependency injection, right? And then I think 5 years ago, Juice came around and it said, hey, we're writing in Java, why don't we write our configuration in Java too? And drop the config files. And allowed you to do things like be able to check in your Eclipse or whatever your favorite IDE is and find the references to all your configuration and things. And it was much smaller, like 500K, or even, I think maybe even smaller than that. Dagger was made by Crazy Bob and Jesse Wilson and the folks that made Juice that were formerly at Google and now are working at Square, like the credit card Square. This is made to optimize the dependency injection problem a little bit further and also make it possible to use the same model on regular Java as you do for GUID or Android. And so, for example, can you do dependency injection with no reflection? And that's the problem that they're attacking. It's very interesting technology. In a nutshell, it says, okay, do it in Java C instead of at runtime. So basically, if I forgot to wire up something together, Java C will fail. That's pretty cool, right? So inside of Denominator, we wire things together up with Dagger. So for example, this is a JCloud's context builder thing. And so on the left-hand side, you're providing things. On the right-hand side, you're requesting things. And so I'm saying I want to provide a singleton. And if I have like all this, a bunch of methods like this, I'm basically building a graph, right? And there's a couple cool things about Dagger. One is that if you think it through, my graph is validated and compiled into Java code. So that means that it's static, and that means it should be faster than doing runtime analysis and then trying to figure it out as you go along. Probably will have less problems at runtime because your graph's not going to change on you. The other thing that is kind of handy is, especially because it's not runtime, aspects such as singleton or lazy or other things are actually a lot more useful. For those of you who've used dependency injectors that have scopes like singleton and things like that, you'll notice to make it at runtime, they have to sometimes make really coarse locks to get that to work. When you do it at compile time, you don't have as much complexity because you don't have to consider things changing on you And so it's pretty interesting. And at the end of the day, you can look at the code. The classes will end up being named $$ inject adapter. So if I was producing this, I would have a class in my source, my target classes directory called Route 53 API $$ inject adapter, and I can just look at the code and see how it works. It's pretty nice. Dagger's runtime is no runtime because all of it's done at compile time, which means that the overhead of Dagger is, I think, 5 kilobytes. So I can't fathom any dependency injection system, like that, right? Spring was made to kind of like make what was then WebLogic and JBoss, which seemed very heavy, lighter. Juice was made to make Spring lighter, and then Dagger's made to make this lighter. I don't know if we'll get lower than 5K, but I'm sure someone will figure that out. We use adapters on vendor specifics. So for example, in this JCloud's API, it has a robust implementation of the Dynex service, but we only need a few bits from that. So we adapt out, and we adapt out into the denominator model, which is simpler, doesn't mean that it's not powerful. And our model also has some interesting things that some people will love or hate. One is that anything that is extensible, we implement as extending a forwarding map. And there's a very good reason for this. One is you don't know what your extensions are ahead of time. And we have Java, it's nice and type safe. And we like our getters and stuff. And we know they're not going to change on us. But we don't want to if you don't want to deal with a registration model always, but you do want to be able to facilitate advanced records from any given DNS provider without having a linchpin of coordination to decide what those class models are, then you do this sort of JSON thing, which is you punt to map. And so that's what we do in our denominator, any model that we have that's extensible. So we have this thing called profile, which describes the advanced record type. And we have corresponding getters with the map keys that are enforced when we actually write into the constructor. So we still do the type safety, but for convenience and also for help, just arbitrarily bumping this out into JSON or allowing folks to be able to do extensions without even publishing them. We use maps for things like that. The profiles are the server-side configuration. So these are things like, is this latency optimized for Europe? Or is this, does this have health checks built in, like that it's automatically going to fail over when something happens? That's what we use profiles for. And so, for example, the most important profile for Netflix is a Geo profile, because that's how we can transition, like Argentina, to use a test version of an application that might be optimized for Argentina. Now, when we're looking at managing availability, what we are looking at is a combination of dealing with different territories and also the way that territories are defined in different API models. So we have the UN, we have the ISO organizations, and there's probably a few dozen ways to describe a country or a state. And that's a reality we have. There's a lot of different ways of doing it. I can do it from sort of a geological standpoint. I can do it from a jurisdictional standpoint. There's many ways and many types of depth there. So it's not wrong that the models are a little bit different. For example, inside of Ultra DNS, it's more like the ISO 3166, which means like US-CA for California or AR for Argentina. But in DNS, what we're really doing is, it's not magic. If I know someone's in California, I only know that because I've looked up their IP address. And I have some database that tells me that this IP address is likely to have originated from California. There's at least in DNS, DNS doesn't have the metadata about someone's GPS. So unless you have a service that can actually propagate GPS data, then you can't really guarantee that entity that has an IP address is coming from a specific spot. So that's how it works in DNS. Now, Netflix itself, after DNS, we have our own thing called Geo, which is a service that even can read GPS data and verify locations of folks. But this is mainly just turning the hose in the right direction, knowing that some will have to redirect out, but at least you get the 90-some%. And so that's how we use this stuff. And we use it also to deal with migration. So for example, say we're bringing on a new load balancer for the West Coast, and we want to test that service out, we can just plug states on. We literally do that. We've ranked the 50 US states into basically prioritized buckets based on traffic, and then we can move 2 states at a time, test it out, make sure everything works. And that way we can go through and go back pretty easily. So basically, in availability terms, we're looking to achieve availability by reshaping traffic to places where kind of we know better because we have health metrics about certain things that would allow us to say, for example, Virginia's in trouble. Even if you're in Virginia, use California. These are sort of things that we can do, sort of like override switches we have when we can control based on the client's origin. I can't release the actual traffic distribution per state, but it's very, very interesting. Some states have an order of magnitude more traffic than others, even at the same time of day. So it's not just like the hours of the day going by. There's a lot of different like social behaviors, and people just like particular content more. And so there's a lot of reasons why traffic could be more interesting than just what time of day it is, stuff like that. So we can use these tools to do this. This is just an image of Ultra DNS. They have some pretty interesting analytics tools now for showing distribution and time series data of where client queries are coming from. So this Geo profile, what we have is it's a profile, so we need to know what type it is. It's Geo. The groups that we have in Netflix, typically we have a group per traffic bucket. So for example, for services where we have load balancers in EU, US West, and US East, we will make up a Geo group that sounds like that. And generally it's like this, and everybody else. Because it isn't just that we're serving traffic for US, East and West and Europe, we're serving traffic for the entire world. So we need to figure out which of these groups, when assigned to the right load balancers, can take the rest of the world's traffic, because we don't have API servers in every single data center in the world. Although we do have this massive cache grid, all of our APIs, like all of our REST APIs, are running out of Amazon clouds. And there's only so many regions they have. So we do need to make choices as far as which countries go to which cloud endpoints. This is sort of what the Java looks like. What we do is, this is using Guava. How many here have used or heard of Guava before? Guava is like functional Java and effective Java in a library. It's kind of nice. It adds new types called multi-map and things like that, table, some extra collection types, and some function and predicate logic. So if you like using languages like Clojure or Scala, you'll probably enjoy Java more if you use Guava and Pitch. Basically, what I'm saying here is I want to move the territories that I have, except for California, someplace else. And so I can write code to do that. In reality, we use, our control plane uses Cassandra, and we will have some queries that happen there. So we'll just prepare the entire record set update out of a Cassandra query. But this is how you could do it programmatically in Java. Airline is a project we use. So one of the things about Denominator is that it's a Java library, but we also know that we have a lot of network administrators that use DNS, right? Unsurprisingly, and not many of them would prefer to operate in Eclipse. Like they're not going to say, oh, I need to make a DNS change, let me fire up Eclipse. So we need to make a command line tool to facilitate the reality of this problem domain. And so there's a really cool project in the Airlift repository called Airline. And this basically allows us to write Git-like CLIs. And so things with expected naming conventions for commands and parameters and help statements without as much of the work. And so we're also using a process. Now, Airline, I believe, was originally authored by Brian McAllister, who had this process called really executable jar. And what that means is that you can actually take a Java jar file and execute it without saying Java -jar, that file. You can just // it on a Unix prompt. And it's a pretty interesting trick, and that's baked into our build scripts. So anyway, you mark up a POJO, basically. It doesn't have to implement any interface. That just happens to be an abstract class I have called Denominator command. And so those descriptions and everything will magically place themselves inside the resulting executable. So pretty cool stuff. Now, I figured I've talked quite enough and got enough time to answer some quick questions and also click around and show you some things. So, go ahead.
That thing you said about really executable jar sounds like a very interesting trick. Can you talk a bit more about that?
Yeah, sure. I can randomly click over there. So, let's see. If I make sure. All right. So if I go to, this is the checkout of Denominator. Denominator is on GitHub under Netflix. And if I go to the CLI, now we're using Gradle for the build tool, but you could do this with Maven. There's a built-in Maven plugin called Really Executable Jar plugin. Yeah. If I look at my build at Gradle here, so here's a really executable jar stuff. So Brian's website's called Skype, and this is the wizardry. Basically, what happens is that so a jar you could open in your text editor if you really wanted to. It wouldn't be fun, but it can work. The zip format ignores the header basically before it gets. There's a certain marker in zip format that after which it starts reading and before which it ignores. You can use that header spot and stuff in a shell script that says exec Java. So if you write a shell script that just says exec Java and then you cat to the end of that your jar file, then after that you can just use it. So for example, if I have, right now, we have this uploaded into Homebrew, so if you did like brew install Denominator, it would work, but I already have it installed. But if I just do Denominator version, I didn't have to do Java whatever, but if I look at Denominator itself, oh yeah. Let's see, look at the first two lines of that file. Now there's my thing that redirects me into Java, but if I looked further, I would just see nasty, jar stuff. And I can jar -tvf that file. It's perfectly valid, right? But I'm tricking the file system a little bit, because it thinks my jar file is a shell script now. So this makes for a very easy distribution model of command line tools. Recently, a guy in the open source group we're working with, Shane, he's Digital Sanctum, he added config file support. So Denominator, you can do commands like, I want to look at my Route 53 test environment, and my config file would be Denominator, whatever. I do a list of my zones. One of the things that, this is Denominator 1.1, one of the things we're working on in 1.2 is to make this faster because there's a lot of overhead. This still uses Juice, and Juice is responsible because of a lot of the singletons that are in the existing code. It does take a lot longer than you would expect a command to take. And particularly if you're working with systems administrators, they're not really kind of happy with all these few second lags. They're used to curl and other utilities that just return, like NSLOOKUP, right? If I want to do NSLOOKUP yahoo.com, I would want it to happen quickly, like very responsively. Like 20, now, in Java, we're never going to get to 20 milliseconds because the JVM takes longer than that to start up. However, if we look at what our overhead is, if I do time of denominator using our mock, minus provider mock zone list, then, my JVM is it's not too bad. I happen to know that 100 milliseconds of that is actually parsing the command line arguments with airlift. But you should be able to make a web service call and return in less than a second if my whole JVM only takes 300 milliseconds. So one of the things that's happening now with Denominator is we're working on a new core library that's based 100% on Dagger, so everything's compile time, or as much as we can. And it's called feign, because a lot of the APIs we deal with are feigning restfulness. They're not really restful. They're kind of weird. They're HTTP, but they're not that simple to use. And what feign does is it allows you to use things like regular expressions to parse your responses as opposed to like a JAXB thing that would take you 100 milliseconds to initialize or longer. And it also is completely written from ground up in Dagger and Guava only, which means that the jar file, even with 5 providers, even every dependency included, is 2.5 megabytes. So that's very fast for Java to launch. It's very fast for it to scan the class path. And because everything's woven together at compile time, the processing is very fast. So the overhead dropped. When I have an example of working with this, where the overhead dropped from 680 milliseconds to 50. So that was kind of cool. And basically, what feign implies is you end up with a factory. So I can create new instances of a marked up API that's marked up with like JAXConf annotations, and then the couple extended ones. And I can make many APIs out of that. Now, at Netflix, we have some pretty interesting concerns because a lot of our services are looked up via Zookeeper. We have a lot of dynamic service discovery going on. So when we want to find the URLs for our services and how we actually interact with them, we need to be able to do that at runtime. So one of the things that feign optimizes for is that you can not only dynamically change the URL, but you can dynamically change any part of the request before it's sent, which means that I can strip auth tokens from here, use this different service, I can fall back to something else, and I have a very simple interface just using a Guava function, in equals out, and do that. So fein's a pretty exciting tool, and that will result in Denominator 1.2, which should hopefully be at least previewable in the next week or two, return a command like from Route 53 in about a second. So at that point, the only way that your network administrator would know that it was written in Java is if you told them. All right, I'm going to switch right back. I think I probably only have 1 or 2 minutes, but I promised I would go to the cloud price, so I don't want to leave you without that. So here are the categories of the 10 categories. Now, some of you have heard of monkeys. Those are the things that they're like our cron jobs, and they look at things and they report, and they sometimes take action, sometimes kill things. Do we have ways of contributing to code quality that we haven't thought up? Like sometimes people looking at Netflix code may say, man, you guys should be doing this, or it so sucks. Well, here's your opportunity to show us and get fame, glory, and 10K. Portability enhancements would allow you to run Netflix on different languages or different clouds or whatever stuff you might be interested in. I can read all these categories to you, but there's 10 categories. That's the important thing. And then there's we know we haven't figured out all the interesting things you might come up with, so there's a Judge's Choice Award for the category that doesn't exist. The process is we're underway. Every contribution has to be Apache licensed, so we can sub-license it out to folks in Apache license. So if it ain't Apache, it ain't going to be accepted. Still time. The entries closed on September 15th, so we highly expect a lot of them on September 13th. And then the award ceremony, our Emmys, is going to happen at the Amazon reInvent conference. And that's the judges will be selecting from nominations that were categorized and suggested through the engineering team. The entrance, if you can follow those lines, basically myself and others in the team will help filter these into the right categories. The main responsibilities from the entrance are just go to GitHub. Netflix Cloud Prize is a repository. It has instructions. They're not too difficult. So there's not many rules as it is like in Netflix in general. But make sure your code works at least if it's code. And the more traction, the better. So we are in the cloud, but we're not about pie in the sky. Everything on Netflix open source repository is used in production. So if you have something that's working and also has traction from someone, that's definitely going to bump you into the higher consideration categories. It's not just cash. You also get 5,000 Amazon credits. I always forget to mention that, but for some people, that's pretty important. Pretty nice. And a trophy. That'd be cool. So and for those who aren't interested in why Netflix does open source, last little bit on that. We spend a lot of time on Netflix working on functionality and scale, knowing that when you optimize for certain things, you're not optimizing for something else. So we're currently working on portability. Denominator is part of that, but also some of the open source work is helping us with that. We have a bunch of projects, but we're working towards a platform that you could deploy and be able to sort of have the whole application lifecycle similar to what we use if it's helpful to you. And generally, what we're trying to do is make sure that we increase our ability to evolve and get shit done. So takeaway is Denominator is what we're using for DNS. It's got cool stuff in it, too. We're fixing the DNS APIs, like the last release of Denominator included a lot of serious fixes that dramatically increase the performance of the clouds. We have leverage to do that. Being Netflix, we're pretty important customers, so we can definitely help proxy some serious issues. And I guess I don't want you to subscribe to anything because I put them in unreadable links. But anyway, we have Google Groups for Denominator. We have a GitHub account. And you can also follow on Twitter. So thanks for coming.